Hello and welcome. In this video, we're going to show you how to program an AT89S52 microcontroller using the Arduino Uno. Now this is useful if you are considering building your own AT89S52 projects. The components that you need: one AT89S52 microcontroller, 4 33 picofarads capacitors, two 12 megahertz crystal. This could be low profile, and 2 push button switch, 2 10K resistors, and 2 10 microfarad electrolytic capacitor. And then you will need one full-size breadboard, which is used for the building the programmer, and a half-size breadboard for the target board. And also we need an Arduino Uno, some connecting wires and jumper wires. Let's take a look at the schematic. The schematic is pretty straightforward. Here we have the AT89S52 microcontroller. Pin 20 and 21 is connected to the 12 megahertz crystal oscillator, and both ends of the crystal oscillator is tied to 33 picofarad capacitor, and the other end of the capacitor is connected to ground. And here we have the capacitor and resistor network acting as the reset, and a push button switch which is connected right across the capacitor, and this is for manual reset. And the 5 volts power supply is coming from the Arduino Uno. And finally, these 3 input pins here, MOSI, MISO, and SCK, is connected to the Arduino Uno. Okay, so now let's prepare the Arduino Uno. Here we have the Arduino Uno, and you need this male USB-A to male USB cable. The male USB end of the cable should be connected to the USB female type connector on the Arduino Uno. And the male USB-A part of the cable will be connected to the computer. And here we have the whole setup, and this part is the computer, and this is your Arduino Uno. Now, beside the hardware, we need the software. So here we will look at how to install the Arduino IDE software. Open up your favorite browser. Here I'm using the Google Chrome. In the search box, type in Arduino software, hit enter, and you'll probably be taken to this page here. Select software Arduino, and that should take you into the Arduino web page. And here you can see the download. Right now, at the time of making this video, the latest version is 1.8.13. My version that I'm using is 0.11. So here is the download options. If you're using Windows 10 like me, I suggest you use this Windows Win 7 and newer. click on that, and you'll come to this page. Here you're asked to contribute if you wish to. If you do not wish to, you just click just download. Either one will download the software for you. Now I would suggest you create a folder to download this software. So here for my setup on drive C, I've created a folder called Arduino install. You may choose other names for your folder, it's up to you. Copy that software into that folder. Double click on this, and that will install the Arduino IDE software. Once that is completed, that's done, go to your task bar, right click at the window icon, and this should pop up. Select Device Manager, click on it, and you'll be taken to this Device Manager. Click on the Ports COM LPT option, and you should find, if your Arduino software and hardware is installed correctly, you should find your COM port number. For mine, it will be COM6. This might be different from your computer, so you make a note of this COM port number, write it down somewhere if necessary, and then look for this icon, the Arduino icon, double click on it, and it should execute or run the software. So this is your Arduino IDE software. Go to Tools, and you will see this drop down menu. Go to Board and Board Manager, click on here, you take it to your Board Manager, look for Arduino Uno, which is here, click on that, select that. Now you see the board now here, it says Arduino Uno. Go to port, select port, click on it, and you will see your Arduino Uno. For me, this is COM6. Again, I have to remind you, this may be different for your setup. So click on this and go to the bottom right corner of the IDE, and you should see, in my case, it will be Arduino Uno on COM6. When you see this, then you know that you have installed your hardware correctly. Now go back to your Arduino IDE, click on File, go to Examples, and then select Arduino ISP, click on that, and you should see this. Now you need to click on this icon for uploading this software onto the Arduino microcontroller. So click on that one. It will then say compiling, and then when it's done uploading, you see this message here, and if you see this message done uploading, you know that you have successfully uploaded the software to your microcontroller. Now go back to Tools, go to Programmer. If this is not Arduino ISP, make sure you select the Arduino ISP option. Okay, click on that. Okay, once you click on that, you are done and the board is now ready. Building the programmer. Alright, so here we have the Arduino Uno, and I'm kind of lead you through to the connections. So from the Arduino pin 13, you need to connect it to the SCK P1.7 pin 8 of the microcontroller, and pin 12 of Arduino go to the MISO P1.6 pin 7 of the microcontroller, and pin 11 of the Arduino goes to MOSI P1.5 pin 6 of the controller, and pin 10 goes to RST pin 9 of the microcontroller. And from the 5 volts of the Arduino Uno, you connect it to the VCC of the microcontroller, not forgetting the EA/VPP pin, which is pin 31, that has to be connected to 5 volts too. And then from ground, any of this ground will do, and connect it to the ground of the microcontroller, which is pin 20. And here is the summary of the Arduino pins minus the power supply. So 10 to RST pin 9, 11 to MOSI pin 6, 12 to MISO pin 7, 13 to SCK pin 8. Alright. And here is the wiring diagram of the from the Arduino to the AT89S52 using the full-size breadboard. So here is the crystal oscillator, 12 megahertz, and the two capacitor, 33 picofarad. This is your 10K resistor, your push button switch, and the 10 microfarad electrolytic capacitor. Alright, so this is the wiring diagram. I like to focus on this part because I don't think it's very clear on the wiring diagram. So I've extracted that part here, and here's a picture of how it should look like. I hope this is clear enough. So this part here is connected to this pin, and the other end of the capacitor is connected to ground, which is this one. And so it's the same for the second capacitor, one end to the crystal oscillator and the other end to ground. I hope that has made it clear. Right, now we need to upload the hex file to the AT89S52. So what is a hex file? Basically, the hex file contains the binary information in ASCII text format. Now remember, the microcontroller is a digital device, so all information inside the device is binary. But humanly speaking, we would not understand the binary information, so you have to the hex file will give you the binary information in ASCII text, and you can open this hex file with any text editor and it will look something like this. Although this doesn't mean a lot to us, but at least it's readable. Alright, at least it's readable. And you need to load this file, this hex file, to the AT89S52 microcontroller so that it can carry out or execute its task. Now there are two ways of uploading the file. The first method is using what we call the command line method. For this, you will need this AVR dude software. This is a .exe file. So what is it? Basically, it's a software utility that can download or upload files to the memory devices like ROM, EEPROM of the AVR microcontroller. And like I said earlier, AVR dude is a command line tool. So to use the command line tool, you need to go to your taskbar, go to your search box on the taskbar, type in CMD, and this should pop up. You click on this, and you will see your command prompt window, and this is where you will type in the command line instruction. Okay, so this is the command line instruction that you need to type. Don't worry too much about this. I explained this. It looks pretty scary. And this is actually one line, one whole line. But I can't fit it in this slide, so it should look like this. Right? It's rather small, but you need to type this thing like this in one whole line. As one whole line, sorry. And here I repeated this command line without the path. This one here and this one here. I've left it empty, and I'm going to show you how an easy way to put this in. Alright, so go to your Windows Explorer, navigate to the program files, go to look for Arduino. Mine is 1.8.11. So Arduino, then go for hardware, and within hardware look for the bin, AVR, and then the bin, and in bin look for AVR dude. Now right click on this, and this window should pop up. Go to properties, click on it, and a window appears. I'm going to extract this part, bring it here. Now I'm going to show you how to put the path into this space here. This is the location of your AVR dude software. This is incomplete because this window is too small. There is another part here, but it doesn't matter. You copy this, copy the whole thing, and then paste it here, and you should see it with the bin, which you can't see it here. Alright, now you see this blue slash, you need to add that in. So copy this, paste it here. You need your slash, don't forget it. And finally, you need to add the .exe extension to this. And so here we have the entire path in. There shouldn't be a space here, it should be this close. Now, for the hex file, I suggest you create a folder in the root directory and put a hex file subfolder here, and in this subfolder hex file you keep your hex files in this folder, subfolder. Now I have provided this file, the blink LED byte and the 1LED V3 ASM with this video. The link is below this video, so when after the video you can check it out. Now go back to this part here, highlight this file. This is the file that I want to upload. So right click and this window pops up. Go to properties, click here, the window comes up, and you copy this file, this path, sorry, and paste it here. Add in a slash, copy this file and paste it here, and this time you need to add in the extension .hex like this. So both parts are now complete. I just want to quickly explain this. No, so this is the control code, and this is the configuration file for the AVR AT51.conf. I provided the file for this in the link below. This is small c minus small c as compared to minus big C here, and you type in the name of the programmer. In this case is STK500V1, and here is the COM port number. Remember, my COM port number is 8. For you that might be different, you need to check it out. And minus small p, this is the device that you're using. In our case it's AT89S52. And finally minus b here is 19200. That is the baud rate that you need to type in. So once you're done with all this, you hit the return key, and that's it, you're done, and that will upload your hex file to the microcontroller. Now if you don't like doing that because it's way too tedious, there's a second method, and this one uses the GUI, graphics user interface, and the file that you need is this AVR_GUI_AT51. You can download it from this particular website. It's free. If you don't want to visit this website, I provided it at the link below this video. Okay, I assume that you have downloaded the file. Create a folder. In my case, I've created an AT51 folder, subfolder AVR_GUI_AT51, and then I extracted the file. Remember, it was a zip file. Extract it in this folder, and you'll find this particular icon, which is the AVR.GUI. Click on this one, double click on it, and you'll probably, the first time you run it, you'll probably see this message: invalid file name. Ignore that, just click OK. Alright, if you see this message the very first time you run it, you just click OK, and this window will pop up. Now here it asks for the location of your AVR.exe file. Remember, this is the one that we have been doing this in the command line. I'm going to repeat this at the top if this is too small, so you need. Now you may need to type this in the first time, or you may use these 3 dots or the ellipsis. You click on this and probably you can navigate it to this destination here. If that doesn't work, it may not for the first time, then you need to type it in. Next comes the location of your alternate conf file. Now this is the AVR AT51.conf file. I suggest you drop it in the root directory of your C drive. For some reason this software does not recognize the the AVR AT51.conf file. You won't be able to see it if you use this ellipsis to try and find it. So I suggest you type it in manually, and then here you put in your COM port. For mine is the COM 8, and here too, this one you need to type. If you click on this down arrow, you should get a list, but the very first time you run this thing, you may need to just type STK500V1. You may not need to do that, just type it in and press enter, and then you need to type in here the -P, the device, this one, and then finally, not forgetting your baud rate, that's 1900. So I've repeated all this in red for you to see, because this may be too small. Alright, so just persevere with it. It does work. I've tried it on 4 different computers, 2 desktop and 2 laptops, and it does work. Alright, it does work. Now click on the memories. Alright, here you type in the path to your hex files, or you may want to try out the ellipsis. If that doesn't work, then you type it in. This manual typing in, it's only required at the very first time you use it. Other than that, after that, it should work. And then when this is done, you click on, I've written this here again for clarification. When this is complete, you click on this, and it should run, and this will flash, this will be displayed, and once it's successful, it says thank you. So let's have a look at this. Here is writing the hex file, and here is verifying it, and finally when it's done, it says thank you. And you notice at the bottom here, that's your command line. Alright, so when you see this message, then you know your file is uploaded. The target board. Now once the hex file is uploaded, you can remove the connections to the RST, SCK, MOSI, and MISO. You can remove those connections, and also remove one of the power lines. In my case, I remove the 5 volts, and then remove this chip, the microcontroller, and plug it into the target board. Basically, the target board, the circuit here, is identical to the programmer. So you've got your electrolytic capacitor connected to a switch. Across it is a push button switch, and one end of the capacitor is connected to the RST input with the 10K resistor, and this is your crystal oscillator, which is 33 picofarad capacitor connected. One end, the 2 ends is connected to the ground, and each capacitor is connected to the oscillator. This circuit here is exactly the same as the one used for the programmer, with one difference. That is, we have a 220 ohm resistor added to pin 1 of the microcontroller, and the other end connected to a free slot, and that is connected to the the anode of the LED anode, and the cathode is connected to ground. And don't forget to connect the 5 volts to this rail here, and ground to this Once the power is applied to this circuit, you should see this LED blink. Here's a picture of the target board that I built. And what follows would be a video of the LED flashing. Okay, so that's it for this video. Now you have a AT89S52 programmer for your hardware projects. Thank you for watching. See you in the next video. Bye.